Okay, so the problem here says, suppose that for these data points, X represents a person's age in years, and Y represents how far he or she threw a baseball in yards. Enter the data in list 1 and list 2, and then find the line of best fit and the correlation coefficient R, and interpret the results. So if you take a look at the data points here, notice that the X values represent a person's age. So we have a 7-year-old here, a 10-year-old, and all the way up to two 19-year-olds. And notice that the Y values tell you how far that person threw a baseball in yards. For example, the 13-year-old managed to throw the baseball 60 yards. And we have the 19-year-olds, one of the 19-year-olds threw the baseball 115 yards, and another 19-year-old threw the baseball 148 yards. So that's what these points represent in this example. And let's take a look at Desmos and see if we can figure out what these points would look like before we get started. I went ahead and typed these points into Desmos. And by the way, Desmos will graph the line of best fit, and it will give you the equation. But I will leave it up to you as sort of a project to see if you can figure out how to do that. Now, if you look at this, if you look at these points, and again, the X value represents a person's age, and the Y value tells you how far they threw the baseball in yards, I can see here that I have a positive correlation because it looks to me like that as the age goes up, it looks to me like the height of the ball, or excuse me, the distance the person throws the ball goes up, right? And I can almost imagine a line passing through these data points here. So it looks to me like we do have a positive correlation. It appears to be linear. And I would like to know the strength of that line. In other words, I'd like to look at the R value. And I would like to figure out the equation of this line of best fit. So to do that, I'm going to switch over and we're going to take a look at the graphing calculator here. The first thing we're going to do, if our lists are clear, is we're going to enter the X values in list 1, and then we will list the Y values in list 2, and then we will go from there. So I have a 7-year-old, I have a 10-year-old, I have a 13-year-old, a 16-year-old, and I have two 19-year-olds. Okay, and then if I go to the other list, the 7-year-old threw the ball 31 yards, the 10-year-old threw the ball 69 yards, the 13-year-old threw the ball 60 yards, the 16-year-old 110 yards, the first 19-year-old managed 115 yards, and then the other 19-year-old 148 yards. So I have put all of these data points in the list, and now I'm going to go to Stat, push the Stat button, and I'm going to go to Calculate. And once I go to Calculate, I'm going down to number 4, which says Linear Regression. I'm going to select that one. Since it's reading from list 1 for X and list 2 for Y, I will leave it as it is. And I will just go down and I will select Calculate. And if you look at this, we can see that the R value is very strong. The R value is approximately equal to 0.934. And 0.934 is very close to 1, right? We said that R has to be somewhere between -1 and 1. And we said that no correlation is going to be somewhere close to 0, maybe somewhere in here. But we have an R value that's 0.93, so it's going to be like almost up here, which means it has a very strong positive correlation, which means our line of best fit is a very accurate model. And the line of best fit, according to the calculator, is the line Y is equal to AX plus B, and A is equal to 8.18, there's the A, X plus B, and B is actually negative for this problem, so I'm going to subtract B, and B is negative 25.73. And I chose to round to 2 decimal places, and that's fine for these types of problems. What does that mean? Well, since I have a very good R value, right, because it's close to 1, if we had gotten negative 0.93, it would have been down here. That would have been great. It would have just been a negative correlation. But since I have a strong positive R value, that means this line here is a very good estimator for how far someone throws a baseball if you know their age. For example, if somebody happens to be, let's say, 17, we didn't have any 17-year-olds, but I could use this model to predict how far a 17-year-old would actually throw the baseball. So let's do that. 8.18 times 17, because that's the age I want to know about. And then I'm going to subtract off 25.73. And let me get the calculator here. That's going to give me 8.18 times 17. Then I'm going to subtract off 25.73. And it looks to me like 113.33 yards. So approximately 113 yards. Now this is just an estimation based on this line of best fit, but I have a lot of trust in this model because of the high R value. So I would estimate that a 17-year-old would be able to throw a baseball about 113 yards. Okay, that concludes our topic for today. And now it's time for you to get some practice on your own. Thank you.